and x is positive. So we got e to the negative 2x minus 3 ln x. Now, given what we did in the last few, can you try and think of how you can kind of simplify this? So you want your integrating factor to be as simple as possible. Okay. Okay, so what we're going to do is we're going to say this is e to the negative 2x times e to the negative 3 ln x. What's the point of me doing that? I'm not just doing it for fun, because I'm going to be able to simplify this and get rid of, the e to the ln of something, right? Okay. So I'm going to get e to the negative 2x, put the negative 3 up, times e to the ln x negative 3. So what's your final answer going to be here? Well, this is log base e, so guess what? My answer is just x negative 3 times e to the negative 2x. And that's my integrating factor. Okay. So now I'm going to do some examples of full solutions. So not just finding the integrating factor, but what happens when they make you solve it after, which is most questions, right? But they do definitely sometimes say, what's the integrating factor? So read it carefully because you don't want to do the whole thing if you don't have to, I guess, right? Okay. So solve the linear equation here. All right, so on your own, I want you to get your integrating factor, and then I'm going to show you how to solve it. Okay, so what's I? Have a go at it, and then we'll solve it. Okay, so dy by dx plus 2 over xy. This would be if I subtract my exponents x to the negative 4. So everything in front of y, including the sign, is p of x, and everything on the right, once this is a 1, is my q of x. So my integrating factor is always e to the integral of p of x dx. Okay, so what do we get? E to the integral of 2 over x. And so e to the 2 ln x. And so if you bring the 2 up, we're going to say a final answer of e to the ln x squared. Ln is log base e, so it's just going to be x squared. So that's our integrating factor. Okay, any questions about that part before I actually solve it with you? Okay, so in terms of our solution, we have v of x, y, equals integral v of x, q of x, dx. So v of x, y equals integral v of x, q of x. So v of x is x squared. Y is always just itself, y, equals integral v of x, which is x squared, times q of x negative 4. Okay, so here, there's no such thing as a product or quotient rule for antiderivatives, right? So if we can't get rid of the product, it's a substitution, but this is easy to get rid of, right? Multiplying same base, add our exponent. So it's just the integral of x negative 2. So integrate the right, and then just divide to solve for what? So integral of x negative 2 is x to the negative 2 plus 1, so x negative 1 over negative 1 plus c. If you forget your c, you're going to be in big trouble, okay? Because in this case, when we divide by our x squared on the left, which was our v of x, it's not going to be just a constant, because think about this. If I put all of these over x squared to get my y, this is c over x squared. That's not a constant, because it's not a constant divided by a constant, so be careful. This is a constant times x negative 2, right, if I bring it up. And the x is a variable, so make sure that's in your answer. Here I can subtract my exponents. Negative 1 minus 2 would be negative 3. And this negative can just go out in front. Now, you could put it on the bottom and say negative 1 over x3 plus c over x2. That's fine too, but a lot of times they do write it with a negative in the end. So one of these two. But it's not like inseparable where you get, a constant times a negative is still a constant. It's going to be the constant divided by whatever your v is. So just be aware of that, okay? Be super, super careful. And that's a big difference between linear and separable. Okay, questions? Okay. So for number 4, solve a linear equation, then I'll show you how to put the initial condition in. The initial condition is really not any different than what we did in separable. It's just, subbing in at the end. Okay, so go ahead. What's your integrating factor for this one? What would I be? Or v of x? I guess in v of t now. Okay, so it's already good in terms of form. So du by dt plus 3u of t equals e to the negative t. So everything in front of u is p of t, not x, it's t now, and this would be q of t. So I'm hoping your integrating factor, your I or v of t, is e to the integral of p of t, which is really just e to the integral of 3. So my integrating factor is e to the 3t. So if you got that, you're good to go. Questions? Okay, so the solution for linear is v of t u of t equals integral v of t q of t. All right, have a go at it. You've got your v of t. U of t is just u, just like it was y. Integral v of t is here, and you have your q of t. All right, go for it. And then I'll show you a hard one. Okay, so v of t is e to the 3t times u equals integral v of t e to the 3t times q, which is e to the negative t. Okay, so I guess I can multiply with the same base, add the exponents, and just say that's integral e to the 2t. Okay, so integral of e to the 2t, well, remember, derivative would be times by 2, and antiderivative is e to the 2t over 2, plus a constant. So that's our solution before we find c. So it's easier to solve from this before you actually solve for u for the initial condition. So it's easier to just put it in before you divide. It's up to you. You'll get the same answer, but it's a little harder sometimes. So this is t is 0 and u of t is 3. So e to the 0 times 3 equals e to the 0 over 2 plus c. That's 1, that's 1. So c is 3 minus a half, or 6 halves minus 1 half is 5 halves. So if I then put my c back in there, I've got e to the 3t times u of t is e to the 2t over 2 plus 5 halves. So go ahead and write what would your solution be now then. So we divide everything by the left, which is really going to put e to the 3t on the bottom here. So I could say 1 half, subtract my exponents, 2t minus 3t is negative t, and then plus 5 halves, and I'd probably just write it like that on the top with the negative exponent. Okay, you guys are doing awesome. We're almost done linear, and then we'll be on to Bernoulli. So go ahead and take another break. Come back at 8:15, and we'll carry on, okay? Take a break, get some food, and I'll see you back soon. Thanks, guys. Hello everyone, welcome back. So just to remind you of a few things, I'll show you my email in case you weren't here at the start, just in case you have questions. And your solutions are all in your account. So try and tackle some booklet questions first and then check your answers. And of course, save the exams until you've studied all those equations and kind of memorized everything, and then try an exam and treat it like the real thing. So don't look at the answers. You do have a printable equation sheet in your prep account, so you can print it out if you like. And you've also got a Python review and a video of that, okay? Just for some basic stuff that they tend to ask on exams. So there's usually a couple questions. And what else? Equation sheets in there. So I think that's it. Video. So video will be up tomorrow, sometime tomorrow afternoon or evening for the first day. And then after tomorrow's session, a day later for that one, okay? And of course, if anyone couldn't make today, they can still sign up, come tomorrow, or even sign up after that and watch videos, okay? So I will just remind you of my email for anyone who wasn't here. It's in the front. I think it's on page 1 or 2 here. So yeah, page 2. So Tina, RESP at hotmail.com, okay? If you have questions that come up, by tomorrow, you can ask them, but after the session, then you can email me. Okay, so we're back to linear and we're just about done. So we're on page 64. Session tomorrow is at 10 a.m. 10 a.m. till 2:30. 2:30, I think it ends. Okay, so for this one, I gave you the integrating factor just because we've done a bunch of that. So I just want to go through the solution. So v of x, y equals integral v of x, q of x, dx. Okay, so my p of x is everything in front of y, and my q of x is everything on the right. And this is my v of x. So we've got v of x is e to the x cubed, y equals integral e to the x cubed times 6x squared dx. Okay, so here we have, this would be our substitution, right? Remember, it can't be the u here. It can't be an e to this something, because if it was the e to this something, then of course our derivative would have an e, right? E to the x has a derivative e to the x, so it wouldn't work. So we do have to do a substitution, and it is u equals x cubed. So if your substitution is x cubed, what's your du going to be here? What's du? So what do you got? So my derivative, my du by dx, would be 3x squared dx. So if I have to solve this here, well, I only have 3x squared dx for my du, but I have a 6x squared, right? So what can I do here? Well, we can multiply both sides by 2, right? So leave the left side, e to the x cubed y. And then this here would be a 2 du. So 6x squared dx is going to be a 2 and a du. and then we're integrating, and it's going to be e to the u. So here, integral of e to the u is e to the u plus c. Okay, so what's your final answer going to be? Think about your substitution here, and what are you going to end up with? Okay, so your u here will be e to the x cubed y is 2e to the x cubed plus c. So it takes about 24 hours, yeah, for them to get the video up. So tonight's will be up tomorrow night, and then tomorrow's, yeah, it won't be up the same day, especially since it's the weekend. So it's usually the next day. Okay, so the final answer would be to divide everything by e to the x cubed. And remember, it's not just a constant, right? So this is a constant over an e to the x cubed. So it does have to appear in our solution. These can cancel, but then this is like c e to the negative x cubed, right? It's not just a constant. It's a constant times something involving x. Okay, so we've done tons of linear, tons of separable. I'll show you a couple more little things, and then we're going to do Bernoulli, okay? Okay. So this one here, in terms of linear, we talked about if Q of t, it's homogeneous, but you could still solve it as a linear, but I would personally prefer to do it as a separable, but it's up to you, right? We've worked through tons and tons of separables, so you can work through that later if you want to. Okay. So look at page 66. And this came up on an exam once. So if y1 and y2 of x are solutions to an inhomogeneous linear differential equation, so that y of x is a y1 of x plus 1 minus a y2 of x, then here, if we have an example, if y1 and y2 are both solutions, and they give you this equation on the exam, then we got to say, well, what would another solution be? So another solution, either of these numbers could be a. So one example is, if a is 6, then 1 minus a is going to be 1 minus 6 is negative 5. And so another solution would be a, which is 6, y1 of x, and then 1 minus a, which is negative 5, y2 of x. This is a way to find another solution that will work. Okay, so if y1 and y2 are solutions, so is this a solution. Okay, a y1 of x plus 1 minus a y2 of x. Now, there's a different one that they can talk about, which is this example. So something like this was on the exam once. And so here's a differential equation. So third derivative minus second derivative minus 2 times first derivative is 0. That's a differential equation. And the question asked about, which of the following are solutions? And it turns out the answer was all of them. And so if we have the answer, let's say in part A, the answer was y equals e to the 2x. Well, to check if this is a solution, I could do the derivative, then the second derivative, and the third derivative, and put them in there and see what I get. We did this at the start, didn't we? So if y is e to the 2x, the derivative is e to the 2x times 2, and then e to the 2x times 2 times 2, which is 4, and then times 2 times 2, 8, etc. And as long as it gives you 0 each time, then it's always a solution. So there's that one, and on the actual exam they had I think 4. And so each of these is a solution. So, and there was another one here that was also a solution. y1 minus y2 was also a solution. So this here is going to work for all answers in this equation. So all these different solutions all worked, okay? Now that's different than the one we talked about before, because the one before on the last page was homogeneous. This is an inhomogeneous, okay? This is homogeneous. The one before it was inhomogeneous. I said it backwards, right? Okay? So this one, if they say that y1 and y2 of x are solutions to a homogeneous, this one's homogeneous because it's 0. So if we have two solutions, then so is a number times one of the solution plus a number times the other solution. And we proved it here, right? We took two different solutions and we took, well, the subtraction of them, but this one minus this one is like a minus b, so a is 1 and b is negative 1. Okay, so it will work for any multiple of those solutions if it's homogeneous. Inhomogeneous is on the other page, right? So you should memorize that, I don't know, conclusion, I guess you would call it, just in case it comes up on your exam, okay? So page 66 and 67 for the two. Now, I said to you, with that question where I was doing ln absolute value, and I said, well, x is positive, you can get rid of the absolute value. Remember I said to you that there was one time where they talked about an example where, it would have both cases. So in the solutions, I put both cases. If it doesn't tell me an initial condition or it doesn't tell me that t is positive, then I put both cases in. But I've never seen it come up on the exam, okay? I'll show it to you just in case, but I've never personally seen it come up. So it's on page 68. It's really annoying. So if this is our equation, we have P of t is here, Q of t is here. And of course, since we have P of x or P of t divides by t plus 1, then we know we can't divide by 0. So the domain is everything except negative 1, which we write like this. We also know that there is an initial condition of u of 0 is 1. So if we're looking at 1, right, this is positive 1, well, which part of the function is this in? Positive 1 is in this part, right, between negative 1 and infinity. It's not below negative 1. So when you go to do your v of t, your integrating factor, e to the integral of p of t, technically, integral here of 1 over t plus 1 is ln absolute value t plus 1. But because it's the positive case, we can just take off the absolute value and say, it's really just e to the ln t plus 1, which is t plus 1. And then we can go through and solve. And we get our c and we get our solution. But if they were to say, let's say u of negative 2 is 1 here, then in this case, we're looking at this t being a negative, right? T is negative 2. So it would be in the other part of the domain, which means it's the negative case. So then when you get your e to the ln absolute value, it's really negative t plus 1. So think about it. If in one case you had no negative in front, in the other case you have a negative in front, you are going to get a different answer, right? And so you get a different c and a different final solution. Okay, so they do talk about that in the textbook. You know how you have the textbook from Dr. Wild? They do go through all of that, but again, I have never seen it come up on an exam. So I guess it's possible, but I don't think it's too likely. But that's anyway what you'd have to know, okay? Okay, questions? Ask questions. You can ask me questions tomorrow if they come up. You can email me questions after that about a booklet question or whatever. Yeah. Yep. Okay, Bernoulli is, let's face it, a real drag. It's not very much fun at all, right? So, you remember we talked about the form kind of in the first 5 minutes, didn't we, right? Where we have this y of t to the n. Now, for Bernoulli, you kind of have some more memorizing to do. So to solve a Bernoulli, you're going to do a substitution. U is y to the 1 minus n is this exponent here. So if n is a 7, then your substitution is u equals y to the 1 minus 7. If n is 3, then u is y to the 1 minus 3. And this is the equation that you're going to solve. So you do need to memorize this. Okay, so du by dx plus 1 minus n times u p of x equals 1 minus n times q of x. Now, this is just telling you that you guys know this already, but if you have a y squared, a y4, or a y6, or a y8, any even, then of course when you take the square root, you'd have to have a plus or minus, right? So keep that in mind. Okay, if you don't have an initial condition, then you'd have to have both. So this is Bernoulli. Remember, if it was like that, it would be linear. But because it has this extra term, then this is a Bernoulli equation because of that y squared beside it. So first of all, here is making my substitution. So we have y to some number n is y to the 2. So that means our exponent here is a 2. So my substitution is going to be u equals y to the 1 minus n, or y to the negative 1. So that's my substitution that I'm going to make. Then I want to write a new differential equation, and then I'm going to solve it. Okay, so first step, use this formula. Same formula every time. So whatever this exponent is, basically you're going to do u equals y to the 1 minus that exponent. Okay? Now, your new equation is going to be what we have up here. So let me write it out for you. Du by dx plus 1 minus n u p of x equals 1 minus n q of x. So now we have to get our equation, and we'll kind of simplify it a little bit, right? So I'm going to have du by dx plus n is 2, so 1 minus 2 times u times p of x. Well, p of x is the same as it was before, what's in front of the y. And q of x is what's on the right, but not including, the part with the y. So just the normal q of x, like if you didn't have this, right? So we've got p of x is 4 over x equals 1 minus n, so 1 minus 2, and q of x would be x to the 3. And now it's going to be linear. It's going to be a linear equation that we're going to solve. So 1 minus 2 is negative, so it's negative, and then really I have 4 over x times u. So I'm just going to write minus 4 over x u equals negative x cubed. And now, guess what? Now it's down to the same thing we did in the last section. it's now linear. But at the end, we'll have to sub back in. So that's the difference, right? And we do also have an initial condition here. Okay, x is positive and y of 2 is equal to negative 1. Okay, well, I hope that you're all very good at finding your integrating factor now. So go ahead, write down what you think your integrating factor is for this equation. I think you can probably fit that there, but I left you, lots of room there and then, room on the next page as well. But I think you can probably fit your integrating here. It's up to you though. Okay, so my integrating factor is e to the integral of p of x dx, and that's e to the integral of negative 4 over x. So it should be negative 4 ln x. X is positive, so we don't really need to worry about that. So it's just going to be ln x to the negative 4 ln x. And then we could just put the negative 4 up top, right? So ln is log base e, so our integrating is just x to the negative 4. Okay, so now we have to solve, right? So we're solving this equation. Our p of x is negative 4 over x, and our q of x is negative x cubed. Okay, so I'm going to have to flip to the other side to continue just because no space left. Okay, so just let me write this stuff down. So v of x that we got was x negative 4. P of x is negative 4 over x, and q of x is negative x3. Okay, so we're solving a linear differential equation. So we've got v of x, u of x is integral v of x, q of x. So x negative 4 u of x equals integral x negative 4 times q. Okay, so finish that and solve it for u. So x negative 4 u of x, let's see, multiplying, we can add our exponents. So it'd be just x negative 1 with a negative, which is really negative 1 over x under the integral. So that means we've got x negative 4 u of x is negative 1x plus c. This is not an integrating factor, so it does obviously need the absolute value, right? Okay. So what's the easiest way to get u of x? You can divide everything by x negative 4, but to get rid of the x to the negative 4, you could always just multiply by x to the positive exponent 4, right? Because x to the 4 plus negative 4 would be x to the 0, which is 1. So that's easier. You can put everything over x negative 4 if you want, but it's not really as simple. So let's just say u of x is then x to the 4 times this, right? Okay. So we need our initial condition was y of 2 equals negative 1. So that's x, and that's y. So what's our u going to be here? Well, u is y to the negative 1. So just make sure you don't put this in like for x and u, right? Because it's really x and y that we have in the initial condition. So remember our u was what? My u was y negative 1, right? So from when I started, u is y negative 1. So what's my u? Well, right, if negative 1 is going into here for y, it's negative 1 to the negative 1, which I know is kind of weird, but a negative exponent just means put 1 over it. So it's really just a negative 1. So now I can substitute that, and x is 2. So that's our initial condition. So u is negative 1 equals 2 to the 4 times negative 1x plus c. Oops, gotta put the 2 in there too, silly me. And I mean, if it was a negative x, we'd absolute value make it positive. Absolute value of 2 is clearly just 2, so that's just 16, negative 1, 2 plus c. Okay, so now we need to know what's c. So maybe you want to multiply this out. There's different ways to do it. So it's kind of up to you. But if I solve this for c, I just bring that over and divide by 16. And then I have to go back to the equation that I've put kind of a cloud around here and put my c back in. There's usually an initial condition given in Bernoulli because if you didn't have one, it would be a lot easier, right? Because then you wouldn't have to sub everything in. So yeah, I don't think I've seen a Bernoulli without an initial condition. Because then we'd kind of just be done here, right? We could just multiply by x to 4, so this would be done. And then really, Sandvika, we would just put u is y negative 1 right there. So we'd have y negative 1 is this, but we wouldn't have a c. And then we just say, well, then y is 1 over that, right? Because if you have y negative 1. So you just wouldn't have to do any of the work to find c. But usually they make you find c because it's more work. Okay, so if that's my c, so we could also, sometimes people might simplify this. So let me show you, you could, we already found c on the last page. Didn't take me as much room as I thought it would. You could also do this, kind of write it as 2 parts, like that. That would be fine too. So remember we had u of x was x4 negative 1x plus c. Remember that? So now we'll put that in. So now remember, what was your u from the very start? U was y negative 1. So now we can just finish getting y. So if y negative 1 is this, right here, then we can say this is like 1 over y. So, 1 over y is this, and y is 1 over this. Okay, I did not drop the absolute value. It's right here, right? We can't drop our absolute value in here. So that's only like in your integrating factor. If you wanted to, if you were told that x is greater than 0, then you can drop it, but yeah, not on a solution. And so that's your y, or y of x, y of t, or I guess in this case, we could call it y or y of x. So a lot of work, hey? Takes me like 3 pages to do them. I've never seen them let you drop it in the solution. So if they're doing that there, that would be very new, that I've definitely never seen in years and years and years of doing these. Okay, you guys want to do another one? Okay, this one is one that was similar to one exam that really, really threw people. Last year, the Bernoulli wasn't so bad, but I think it was the 2 years before that, people said, oh, the exam wasn't bad until I got to the Bernoulli, and it was the worst thing I'd ever seen in my life. So make sure you do all those practice exams, because they can certainly throw some weird things on, for sure. So if you look at this, I mean, first of all, it's not really in the right form because it has x cubed out in front. But also look at the product, right? It can't have a product. We know what linear looks like, right? It's something plus something equals something. There's no product going on. So we need to get rid of this first and also divide by x3. So if I multiply this out, x3 y prime equals y of x plus y of x squared. And then divide by x3 in each case. So how do I make this look linear in a minute? And Bernoulli for right now, I have to bring that term over, don't I? So it'll be y prime of x minus 1 over x3 times y equals 1 over x3 y of x squared. And now it is Bernoulli, right? So this would be my p, and this would be my q of my original. And this is my n. So it's pretty mean, right? Because you've got to do that first. So what's your substitution? Well, that's u is y to the 1 minus n, and the exponent is 2. So u is y negative 1. Okay, write down what's your equation that you're going to use. the du by dx one, and what's going to be the simplified version of that du by dx plus equation. So what do you got for that? Okay, so the formula is du by dx plus 1 minus n u p of x equals 1 minus n q of x. So we get du by dx, 1 minus n is 1 minus 2, so that's just negative 1 u times p of x is negative 1 over x3 equals 1 minus 2 is negative 1, and q is 1 over x3. So my linear equation is going to be du by dx. This would be a plus. I'm going to write this as x to the negative 3, I guess, times u equals negative x to negative 3. So that's the linear equation. And here, well, we can say that's my p of x, and that's my q of x. So go ahead, what's your integrating factor going to be here of the linear? So we get e to the integral of x negative 3. So that's e to the x negative 3 plus 1. So x negative 2 over negative 2. So maybe we write it as negative 1 over 2x squared like that. Right? We could move the x negative 2 down to the bottom and make it positive, and then we usually stick a negative in front or up top. Okay. So now we have our formula to solve a linear. V of x, u of x equals integral v of x, q of x dx. So my v of x, because a negative times a negative here is a positive. Okay, so we've got e to the negative 1 over 2x squared. U of x equals integral e to the negative 1 over 2x squared. And q is a negative x to negative 3 dx. Okay. Excuse me. So that's nuts. There's no way we can integrate that, right? It's an insane product. So it has to be a substitution, right? So I'm just going to write it at the top of the next page so that I can do the substitution there, okay? And what's our initial condition? Y of 1 is 1 and u is y negative 1. y of 1 is 1. Okay, so let me just write this again. So e to the negative 1 over 2x squared u of x is integral e to the negative 1 over 2x squared times negative x negative 3 dx. Okay, so pick out what's going to be your u and du out of this great big mess here. And since we already have a u, let's use w, right? Because we already have a u here. So I don't want to use the same variable. So let's call this our w for our substitution. And then we can do, well, may as well just treat that as x negative 2, I guess. And then we can do dw by dx. Well, the derivative of this would be negative a half times the derivative of x negative 2 is negative 2x negative 3. So really, the negatives cancel, the 2's cancel, and it's really just dw is x negative 3 dx. So take a look at your substitution, your dw, and what you've got up here, and figure out your next step here, what it would be. So dw, that's dw. It's just off by a negative, right? So that's a negative, I can put that out in front, and a dw. And if that's my w, then I'm really just going to integrate e to the w, dw, with a negative. Well, my integral of e to the w is obviously just e to the w, right? So plus c. So that's what I've got. And then, again, do you want to divide? Do you want to multiply by this to the positive? Whatever you want, right? And we can put our w back in right now. So -2 c. So this is the same thing as this, right? So maybe write them both the same, just so it's easier. I know we wrote it like this just so we could do the derivative easier, but maybe, it's simpler if you just put them both the same. So I think I'll just write them both the same in this step. And I don't have to write it out again, just like that. So do you want to divide by this every term? Do you want to multiply by the same thing but with a positive exponent? It's your choice, right? So whatever you think is simpler for you. Either way, it should be gone, except for you should have u of x is -1 plus c times this, and I'm going to move it back up and make it positive. And so that's kind of what I need to now look at my initial condition as well as, what was my substitution for this Bernoulli. So when you flip over, your substitution was u is y -1, and your initial condition was y of 1 equals 1. Okay, so I've got u of x is -1 plus c e 1 over 2x squared. And I had y of 1 equals 1. And in the very first step, I had said my substitution was u is y negative 1. So that means it's u would be y negative 1. So y is 1. So that's 1 over 1, which is 1. So if I sub that in, I can find c. X's are 1. So that's, move that across, 1 plus 1, so that's 2 equals c to the 1/2. So c e to the 1/2, pardon me. So c is kind of weird, 2 over e to the 1/2. I guess you could call that root e on the bottom. So c is 2 over square root e. Okay, substitute that back in, and basically you're done now, right? You just have to solve for your y. And then this is y negative 1. And that's it. That's your y negative 1. So y is, you can put 1 over that. Sometimes I notice that some of the profs, if you put this to the negative 1, then you put that to the negative 1. So you can say y is this to the negative 1. You can also put 1 over this, but sometimes people write it like that. I don't know, it's preferred to some, I guess, right? It's up to you, but same thing. Okay, so that was Bernoulli. So what's next is, unfortunately, applications. So we have to do, well, the hardest one is the IB questions. The population ones aren't too bad. The brine solutions, so like the salt kind of tank questions, those are linear, so they're not too bad. I think IB, most people would probably think that's the hardest in terms of a lot to memorize. Any questions about Bernoulli here? Okay. So applications, so we can first just kind of mention rate of change. So rates of change, we know in equals out, right? So sometimes we talked about like network flow problems, like in Math 1600. So rate of change is the rate of internal change plus the rate of external change. And again, some people think like flow in equals flow out. If a rate of change of some quantity n, or n of t, is with respect to t is proportional to n, then it would just be dn by dt is some number k, some constant k times n. That's proportional. Okay, and this would be, k would be some proportionality constant. And of course you can, test the signs, kind of like we did in our first derivative chart last semester. So modeling with only an internal rate of change. So you did these kinds of questions in class. So I'm going to have you just read through these. And I've given you the diagram for each one. So I think they're pretty straightforward. If something's going in, then that's plus R, right? And if something's going out, like in this one, if you're going in at R milligrams per minute, out at P, then you're going to have a plus R and a minus P, for example. Okay, so read through those and ask me tomorrow if you have questions. So for example 2, we have a tub filled with so many liters, V liters of hot water. The rate of change is proportional to the volume with the proportionality constant of negative 0.2 per minute. Water enters at 2 liters per minute and leaks out at 0.1 liters per minute. So model the volume with a differential equation. So basically it's going out, so it's leaving at 0.1 liters per minute. It's going in at 2 liters per minute. It starts with so many liters. And then this is the proportionality constant, so the rate of change of the volume. So our dV by dt is going to be negative 0.2 times the volume. And then we're going to go in at 2 and then out at 0.1. So it's going to be plus 2 and minus 0.1, which we could technically, excuse me, simplify that by adding them, right? Your units do all match. They're all milligrams per minute. So the type of question that they typically ask on the exam is some kind of salt solution or brine solution problem. So they give you some mixing tank, and they'll either tell you that it's full of so much salt or it's fresh water. If it's fresh water, then our initial condition is 0, 0. Or you can say, if you want to use the variable a like I did, you can say a of 0 is 0. So in other words, at time 0, then there's 0 salt, right? No salt. If it's at time 0, there's 10 kilograms of salt, then it would be initial condition 0, 10, for example. And it says it contains, so the solution going in contains 20 grams per liter of salt, and it's going in at 2 liters per minute. And then it's going out at 1 liter per minute. And sometimes they just have you set it up, okay? So if it's going out at 1 liter per minute and in at 2 liters per minute, first of all, you can kind of model your equation as your change in A, the salt, if A is the mass of salt, dA by dt is the two rates going in minus out A over volume. So dA by dt is in minus out times A over the volume at any time t. So what are the rates going in? We have to multiply. So let's see, let's go down here. So for in, I have 20 grams per liter. That's in. And it's going in at 2 liters per minute. So think about the units there. Grams per liter, liters per minute, those cancel, and that's grams per minute. We have to make sure our units match. Now, A is the mass of salt, so that's in grams per time, and time is in minutes, so that matches too. Now, minus the rate going out, which is 1 liter per minute, so that's liters per minute, times A, which is in grams, and then it's over volume at any time t. Well, the volume is being measured in liters, right? So the volume is on the bottom, and again, you get grams per minute. Now, the volume here that we have to write on the bottom, we have the 20 going in at 2 liters per minute. So 20 times 2, that's pretty easy. We've got 40. We have 1 times A, that's easy too. The bottom, we have to ask ourselves, if the volume is going in at 2 liters per minute, out at 2, then nothing would change. But if it's going in at 2 and out at 1, what's happening each minute? Are we gaining or losing each minute? In at 2, out at 1. We're going to gain